Hi, hello students, welcome to Let's Understand Physics. In the previous video, we have seen laws of reflection. So the two laws of reflection are angle of incidence is equal to angle of reflection, and incident ray, reflected ray and the normal all lie in the same plane at the point of incidence. These are the two laws we have seen. Now see here, in the diagram we have rays and also we have angles, and the angles are always measured between normal and the ray. That is very important. You have to remember this and without any confusion. Angle I is equal to angle R. Other than these angles, we have other angles also. See here, see, without taking normal, we can have angle between ray and the reflecting surface, this side also and this side also. These two also will be equal and they are called as angle of glancing. So angle of glancing or glancing angle is an angle which is taken between ray and the reflecting surface. Generally here, what is our reflecting surface? Mirror. Okay, very important. Remember this. Both the sides angle of glancing will be equal because angle I is equal to angle R always. Okay. Now next, if you don't have mirror, if you are not considering this mirror, this incident light might travel like this in a straight line. But because you have kept a mirror, which is an obstacle for the incident light, due to this mirror, the light is deviating its actual path, isn't it? Now see here, instead of going straight, it is going in the different path. It is bouncing back. So this angle where it is bouncing back, we call it as angle of deviation. Okay, now see here, I am drawing once again the diagram. Now if this is the incident ray, it has to go like this. Due to mirror, what is happening? Instead of going straight, it is reflecting at the point of incidence, bouncing back, and you have normal also here. Without normal, you are not able to mark incident angle and reflecting angle. That's why I have drawn normal. Okay, and angle of glancing also, just now we have learnt that also I am drawing. Now see here, so here instead of going straight as it is going in the other path, so between these two, what is the angle you have? We call it as angle of deviation. You can write angle delta. So angle delta will be how much? We will see now. Okay, now what is the straight line? Angle of incidence and angle of reflection and angle of deviation. If you see, all of them are along a straight line. Now see here, incident angle is between normal and incident ray, right? Now you just see incident ray only, so that is a straight line. So this total angle will be 180 degree. Now see here, I am writing angle I plus angle R plus angle G you should not take because angle of deviation is between reflected ray and the dotted line, which is expected incident ray if you are not having mirror. Okay, that's why angle delta is equal to how much? 180 degree. That is a straight line. That's why straight line angle is 180 degree. Okay, now we have learnt in laws of reflection angle I is equal to angle R. So in place of angle R, I will write angle I. So angle I plus angle delta is equal to 180 degree. So I plus I is equal to 2I. So 2 angle I plus delta is equal to 180 degree. Now this 2I you send that side so that you will get angle delta. angle delta is equal to 180 minus 2i. If you are writing in radians, 180, what you have to write? You have to write 180 value is pi minus 2i. Okay, I hope all of you understood this. 180 minus 2i is your answer. Okay, now after this loss of reflection, we have different types of reflection. Okay, those also we will see now. Different types of reflection are regular reflection and irregular reflection. So, and one more thing, very important, here you have to learn. In regular reflection means if the surface is smooth and shiny, the surface must be smooth and shiny. If the incident rays are parallel to each other, smooth and shiny means mirror, right, for us? So I'm taking mirror, or you can take any smooth shiny surface. If the incident rays are parallel to each other, see, I am taking three incident rays which are parallel to each other, I1, I2 and I3. Now take the point of incidences O1, O2 and O3. Now draw the normals at the point of incidence. Now see here, all the normals are also parallel to each other, so that you can understand the reflected rays will be also parallel to each other. Okay, now from here, whatever the angle, with the same angle it will reflect. For this also same, for this also same. So if you have parallel incident rays falling on a surface, the reflected rays also will be parallel to each other, because the normals are also parallel to each other. With laws of reflection only we can prove this. Understood? So this is regular reflection. Next we'll go for irregular reflection or diffused reflection. So irregular means the surface is not smooth. Then if surface is not smooth, what we will take? Any rough surface. I am taking rough surface like this. Okay, this is the rough surface. Now see here, again you have to take parallel incident rays. I am taking parallel incident rays. Now one ray is falling here and the other ray is falling here and the other ray is falling here. Now if you see, the rays, incident rays are parallel to each other, I1, I2, I3. Now we will take the point of incidences. This is the point of incidence O1, this is the point of incidence O2 and this is the point of incidence O3. Now draw the normals. Now see here, this is the surface. For this surface you have to take 90 degree. Okay, so now incident ray itself is like 90 degree, isn't it? And then for this is the surface. So for this, if you draw normal will be like this. And for this surface also, normal will be like this. Understood? Now all the three normals are not parallel to each other. Very important here, normals are not parallel to each other. Now, with respect to normal only, we can draw the reflected ray, isn't it? Now, see here, very important point. This many times they ask in the exam. If you have normal incident ray, means this is the normal, Now, along the normal, if you have incident ray, what will be angle of incidence? Angle of incidence is angle between normal and incident ray. Is there any angle between normal and incident ray? No. So angle I will become 0. So angle R also will become 0 degree. So that means the angle of reflection is 0. So reflected ray also will be on the same line. Understood? This is very important. So for normal incidence on a surface, you will have incident ray, reflected ray and normal on the same line. Okay. So what you have to tell? Reflected ray will be retracing its own path. Understood? Now we'll go back. Now see here, normals are not parallel. As this is normal incidence, you will have reflection also on the same thing. R1 will be here and I2 is here. Then R2 will be the other side with the same angle, isn't it? Now R2 will be here and R3 will be here with the same angle. Okay. So here, according to the laws of reflection only, you will not have reflected rays parallel. Understood? That's why this type of reflection on the hard surface we call it as irregular or diffuse reflection. But here also laws of reflection are obeyed. So with this you can conclude at any surface the laws of reflection are obeyed. It can be regular reflection, irregular reflection, plane surfaces, curved surfaces, any type of surface. Okay, understood? This is very important. Not only for class 10, for Olympiad exams also, they will generally ask Olympiad and other competitive exams and NTSC also. It is very important point. Using reflection and laws of reflection, they may ask, they may frame different types of question. Okay, and that's why I have taught you the other types of angles also which can be asked in the Olympiad exams and competitive exams and NTSC exam. Okay, and then we will see the image formation by plane mirror. Okay, so I'm using from the first class object and image, isn't it? So we'll see first what is object. So here object means it is the point. We generally take point. We don't take extended objects. We just take small objects. So you can take it is the point from where we are getting incident rays. Means that is the source of light for us. Okay. So the point of intersection of incident rays is called object. Next, image. Image means the point of intersection of reflected rays or extended reflected rays. The same will be for refracted rays and extended refracted rays also. Now as we are seeing reflection, I am telling for reflection. So point of intersection of reflected rays are extended reflected rays. Very important. Remember this. This terminology is very important while writing the exam. That's why first when you are learning light chapter, You must and should learn the terminology. Important things are object, image, next incident rays, all the rays. So incident, reflected ray, and normal, and then about angles, angle of incidence and angle of reflection, angle of glancing, angle of deviation, and mirror. Okay, so all these you have to remember. These are the important terms which you have to remember for writing answers in the exam in the light chapter. Okay, so first all of you learn and understand these definitions. Then in the next video we will see image formation by the plane mirror. Thank you. I hope all of you understood this. Please like, share, comment and subscribe to Let's Understand Physics.